Okay, this video is the first one talking about the build process itself, on how I'm calibrating my printer together with my resin in order to get the best results, because in fact we will come to that a little bit later, but when you assemble the parts of the scale models, you need some tolerance, and you need that tolerance to be as minimum as possible, as little as possible, I would say. And of course, that means that you have correctly calibrated your printing process overall. So when you deal with printing process calibration, the first thing is usually when you deal with any kind of new resin, that's of course the burning layers exposure time. And for this, I'm using something which was available in Calibrating 3D a long time ago, invented by Dennys Wang, which is those little squares there. In fact, I didn't invent anything. I'm just using what other people have invented, especially Dennys Wang, G3D Tech, which is also Lychee Slicer, and also the TableFlip Foundry. So Dennys Wang got some interesting things in order to set up, I would say, and he invented this little square in order to check for the burning layers exposure time, which is usually this little 2 by 2 centimeter by 2 centimeter stuff, and there is also something equivalent in G3D Tech. But what I'm using is that I'm not simply using this, I'm using a big portion of that. So there is a little suction, a little cup here in order to provoke some suction cup, in order, let's say, to assess the resistance of your burning layer stickiness in a way. And I'm not simply using the 2 by 2 centimeters or the 1 by 1 centimeters, but I'm using a big plate, because often I've seen that the 2 by 2 were working fine, but when you have had to deal with a large piece or a large part, for example, with a big surface that is sticking, then you had some little, I would say, stickiness problem in a way. So this is why I've changed that by adding a big plate in the middle. And I want this big plate, of course, to stick when I'm tuning my burning layers exposure time. So that's that. There is not much to say around that. Because that's pretty easy, I would say, to tune, and especially you go from 5 seconds to 5 seconds. Since there is only a few numbers of burning layers, here I'm going for 4, which is what is required in most of the times. But then after that, I'm going to 6 transition counts, because 4 plus 6, it's 10, of course, and 10 times, let's say, the 50 microns is usually the I would say the width of the things that you have on at the bottom of your supports. So this is why I'm using 4 and 6, and then after that you can go to the G3D Tech in order to get the best of those numbers, but that's pretty easy. So that's how I'm using that. Now, then after that, once you've done the burning layers, of course, you have to deal with the regular layers. And that's another piece of let's say, challenge in a way. A long time ago, the TableFlip Foundry found the cones of calibration. That was the version 1, then the version 2, then the version 3. But at the end of the day, I prefer to use the one that are provided by G3D Tech, and which are again into this into cults, so you can find them very easily. And you can find also on Lychee here the secret of calibration, which is really the thing that you need to understand. And I think that's the most comprehensive test that we have right now. So that's easy to look at. Now, in fact, I'm using it like 3 times, okay, in order just to check. And in fact, the way that I'm using it is usually I'm using it, I'm taking one before UV exposure, and I'm checking that it's going well, because going back. You need to make sure that all those three boxes are fitting into one of each other. You snap the little one, put that into the middle one, and you snap the middle one and you put that in the big one. So those are 6, 4, and 2 millimeters width. And in fact, if you are overexposed, of course, you cannot really push them because, of course, they're going to be inflated in a way, and they cannot go into it. And then after that, you have to look at what is called the pillars here. And the pillars, it's a little bit measuring the tensile strength that you have. So you need to be as exposed as you can in order to fit the boxes. And then after that, you need to play on the time, on the weight before print, in order to increase the tensile strength that you have. And so that's very well explained into this into the video that I've shown on the Lychee Slicer. So use it, and that's the thing that I'm using most. And as I told you, I'm using first a version before curing that I keep, and then the two others are after curing that I'm testing that the little box is going into the middle and going into the big one and everything like that. And then I'm tuning the weight before print in order to augment the number of pillars. Now, this said, it seems easy. The problem is that when you look at the numbers that are usually on the bottles of resin, they are very conservative, especially on exposure time and everything like that. Which means that if you start from those values, usually you need a lot of experiments in order to get to something which is pretty good. And that's a little bit the problem that I faced. But at the end of the day, you managed to do it. The little problem is that I've tried that with two resins. So in fact, instead of spending 1 or 2 days calibrating for one resin, I spent 4 or 5 days to calibrate for two resins. Yes, because I wanted to check another resin, and I will tell you a little bit more about that a little bit later. So once I've done that, usually I'm testing what I'm calling the all calibration. All calibration is in fact the old version of the cones of calibration. Okay, this is this one. You remember eventually, for which you need all these to be on a success and all these to be on failure. Then of course I have again my the boxes of calibration of the Lychee 3D Tech, and I have also the TableFlip Foundry, which is the version 3. This was the version 1, in order also to check that this little thing here goes into the cup, and that you have the sword here that should go through the skull, but not through those kind of things. And again, you have a little bit things in order to check for the tensile strength, both on the success and failures type of thing. G3D Tech has also provided on his cults this thing in order to check, I would say, for the precision that you can get with your resins. And so that's the final check that I'm using sometime. Okay, but that's not the only one. I have my own I would say checks that I'm using, and I will show you that just after that. So after these regular tests, I'm using some specific tests dedicated to scale modeling. And in fact, I'm using a wheel that should goes into some axes in a way with some tolerance. So that means that here it's 0.02 millimeters of tolerance, 0.05 millimeters of tolerance. So that means that the radius is 0.05 millimeter less than the hole in the wheel. And that's the same thing for the 0.10 millimeter here. And the same thing here for the little, for those tails in a way. Going from 0.10 millimeter to 0.05, 0.02, and 0. Of course, 0 should not work. 0.02, it's a stretch, and 0.1 should be okay, and 0.05 should be also a little bit difficult to put it. So that's something specific that I'm using in order to check that I can print parts of scale models first, and that the 0.1 millimeter is okay. That's the regular tolerance that I'm accepting. Usually with my calibrations on my resins, on my Mars 4, my Elegoo Mars 4 Ultra with 18 microns of pixels, I can go to 0.05. But I'm expecting that most of the guys buying my models will not go over there. So this is why I'm sticking with 0.10 millimeters most of the time as the basic tolerance that I'm using. And I've seen sometimes the fact that the boxes of calibrations are working, but for example, the 0.1 millimeter tolerance is not working. So this is why I'm using this extra test. And that's not the only one that I'm using specific. So in fact, I'm also checking, I would say, the fact that all the things that we've done with the tensile strength that you've seen allows me to create my models with, let's say, a width of resin around 0.7 millimeters. So that means that here you have three different angles of something which is of width 0.7 millimeters, 0.6, 0.5, 0.4, 0.3, 0.2, and that allows me to check that there is not that much of deformation when I'm using 0.7 millimeters, because that means that I do not have to support like every 2 millimeters for each of the walls that I will use in my parts, in my models and everything like that. And also checking until which width I can go in terms of, let's say, smaller thickness, smaller possible thickness and everything like that. And of course, this part here is a regular part with a 0.7 millimeter thickness. And here you have 0.05 millimeter thickness. Because that's usually the thing that I'm using for the clear resin parts. I will come that much later on this section, but this is what I'm checking. I'm checking that here I can do these 0.5 millimeters. I would say canopies in a way, and that they are sticking very well onto this 0.7 millimeters frame in a way. So I'm using all this. Now that's the theory, and I will go to the bench in order to show you the practice of that. So I explained to you the theory, and now you see here a little bit the practice of that. So in fact, this was using the Elegoo water washable, because I'm only using water washable resins. That was the Elegoo water washable 8K, because there was 8K in the name, so I wanted to check what was the thing. And every time you see here the bottom exposure time, the regular exposure time on the weight before print or before lift or whatever. So, and in fact, you can see a little bit how I went. I think that it's given for 2 to 3 seconds of regular exposure time. And as you can see, I went down to 1.3, 1.4, and everything like that. So I went down first with, let's say, a weight before print that was in the range of 2 seconds. And because of that, that means that I had to go down to something like a regular exposure of 1.3 seconds in order to make sure that the box were fitted, but they were a little bit, I would say, squeezy. You can see here that it's a little bit squeezy there. And then I begin to increase the weight before strength in order to get the proper number of pillars. So every time that I've managed to put the boxes in, you know, I was counting the number of pillars up to this point here when I had 1.4 regular exposure time to 4.5 seconds of wait before lift or print or whatever, and I had 19 pillars. In fact, I went even a little bit further, like 1.5 with a 4.5 weight before print, and in fact, I went from 19 pillars because, yeah, since I'm creating 3 of those, I can count the number of pillars that are there, and in fact, that's a little bit an average over the 3 runs, so that's a little bit more precise that if you have a one single run. And in fact, I went from 19 to 21 pillars with a 32 exposure time for the burning layers, because I've seen that at 25 this thing was kind of sticking out from the plate. This is a little bit bent right now, but that's because I've left that sheet in the sun, so that's why. So I was pretty happy with that. There is nevertheless something with this, and you can see here that I've always using one before curing and the 2 after curing, and you can see here that there is this one is a little bit more shiny just because of that. But that's something that I do not like into this resin, is that I have a very hard time to clean it in a way using just water and regular alcohol or something like that. But nevertheless, okay, I was at a point where I wanted to test it all in a way. So I tested, for example, my tolerance test, and I was a little bit disappointed because my tolerance test was not really, that was really too tight. Now, this may be because I didn't manage to, I would say, remove all the uncured resin in a way. And then, of course, when you cure it, then, of course, it takes a little bit more volume and everything like that. So I have a little problem with this resin is that I do not manage to clean it in a way. So now, of course, when you look at the wheel, then the wheel is pretty good for 0.1 millimeter. 0.5 millimeter is a little tight, okay, but it goes well. Well, no, it's a little bit too tight, okay. And then, of course, the 0.02 millimeter does not fit, and of course, the 0, as expected, does not fit at all. But the 0.1 millimeter is pretty good. And then I tried, I would say, the classical calibration tests, and of course, the box of calibrations worked, but the TableFlip Foundry didn't work too much. I mean, it was clearly a little bit too tight. As you can see, you know, the beer is not going well into that, and also the sword is not going completely through the skull. And so, and furthermore, the sword has some little trouble when getting out, and the V1 cones of calibrations didn't print. So I was not pleased at all with all these experience, and this is why I changed resin. So then I went to the Sunlu water washable dark gray. And in fact, I started again, you know, with around the same lines, like 1.4 exposure time on 4.5 weight before light or before print, in a way. And when I tried that, of course, I didn't get at all, you know, the correct number of pillars. I was really at something like 9 pillars, which is not very good. I mean, if you can see here, the number of pillars, of course, it's only 1, 2, 3 or something like that. So in terms of tensile strength, that's really not a very good result. So I went up into the exposure, keeping the same weight before print, and I went up to 1.5, 1.6, and then 1.7, in which I went from 9 to 12 to 14 pillars in a way. At 1.6, I was kind of happy with that, and if you look at, you know, the tolerance of 0.1 millimeter, first of all, you can see that the aspect of the cured resin is very, very neat. I like it very much in a way. And of course, you can see also that at 1.6, it goes well into the 0.1 millimeter and goes well into the 0.05 millimeter. So it means that you can certainly go a little bit higher, which is exactly what I've done with the 1.5, 1.7 exposure time on 4.5 seconds of wait before light. And so this was my last test. And in fact, you can see that with a little bit of luck, you can remove the boxes. Okay, so that means that it's a good fit. It's a little bit tight, but it's good. Okay. Then, of course, you have my own tolerance test with 0.1, which is working very well. And you have the 0.5, which is working also fairly well. So I think I like that. And of course, then you have the wheel, which is going well into the 0.1 millimeter, and is going well also into the 0.05. Now, of course, at 0.02, it begins to be a little bit too tight. And also, all the previous calibration tests were working. Like if you look at the first version of the cone of calibration, remember you had something that should be a success over there with all the cones linked together, and something aside that would be all failed. And you can see here that it's pretty good. For the TableFlip Foundry, that's the same thing. That the beer is going into the mug very well. The sword is not going into those two holes, but is going through the skull pretty well. Okay. So in a way, I had almost everything perfect. Of course, the codes of calibration are working. And here also, I have the little precision dice that the G3D Tech, and I will show you a little bit some high-res photos that I've done on that. And then after that, I've managed to glue a little bit the thing. And the last thing, of course, it's the resin width, okay? And you can see here that at 0.7 millimeters, it's pretty straight and everything is okay, okay? 0.6, 0.5 also, it's pretty good. And you can see here that this thing is also 0.5 millimeter. Now, of course, 0.2 millimeter is a little bit difficult, okay? So that means that you need to support it very well, but nevertheless, it's the tensile strength is strong enough in order to keep that as surfaces in a way. And 0.3 is okay. And in fact, that's completely in line with the fact that the pillars, when I have only 17 pillars, I mean, every time the 0.2 millimeter pillars are printing, okay, which is something which is important for me, because first of all, my small supports are 0.2 millimeters, and also sometimes I have 0.2 millimeters like wires or things like that I would like to be able to represent in my models. So in fact here I had a kind of a perfect fit in a way, and this is why I've selected the Sunlu water washable with these settings in order to go further. So the last thing that I wanted to show you with this Sunlu resin water washable is the different pictures that you can get of the dice that is pretty high res type of stuff. So you have here one face. Frankly, I don't know exactly how to interpret it in a way. You have another face where you can read even, the number of degrees and whatever. So knowing that this is the side of my thumb, this is not bad. And of course, the last one is the one which is a little bit easier to understand, is that you can see that we can read the letters both in when they are going out or when they are going in, and so it's pretty good, I think. And that means that it's the resin that I will use going on. last point that I wanted to show you about the process in order to keep trace of everything. So I'm using the history of Lychee, so I think that's a pretty convenient feature, especially when you are doing those kind of tuning. And as you can see, I kept all the time the fact that I've been in a success or not success, for example. And little by little, I refine my way of naming the files that I was generating. And in fact, there is always the burning layer exposure time, and then the regular exposure time, and then I would say the wait before print time. And if you look at that, you know that I'm commenting each of them, okay? And that means that doing this, I'm able to, in a way, keep trace of everything that I've done. And as you can see, as soon as I've hit, the box cal, Sunlu, the 25, 17, 45, then I'm all good from there on. So I think that's the thing that is pretty important. So my advice to you is that you should always keep, this convention about the exposure time. Burning layer exposure time, regular layer exposure time, and wait before print. And in fact, even when I'm printing now my files for my models and everything like that, I keep this little suffix that I'm using in order to remember a little bit what I'm doing. Because especially, so now I'm stabilized. So now when I look at this kind of configuration here, it's always the same thing. But I've kept, of course, the same configuration file that I changed throughout. And in fact, this is why it's important to keep this naming convention, I think. And my advice to you is that if that's useful for you, that could be good. Last little comment. Um, this was not very easy. I mean, as you can see, that's a lot of different tests in order to get there. I spent like 4 full days because I had two resins, and I was really hoping that the first one was working very well. But yeah, it was kind of a nightmare in order to get there. But again, I needed that because I need my printer with my resins to be well calibrated. Also, something which is very important is that in order to keep all my experiments, in a constant environment, I'm using a heater, an internal heater in my Mice 4 Ultra, and which is set up at 25 degrees Celsius.